What's up, Math Mob? We're back at it again with another video, this time talking about similarity. Our focus question today, how can you determine if two figures are similar? So I'll let you get started on your notes. If you want to pause the video, go ahead and do that. And when you're ready to continue, unpause. Okay, so our warm-up. Use what you know about operations and their properties to write three expressions equivalent to the expressions shown. So one property that we've learned about is the distributive property. And when we have parentheses right here, usually that's an indication we can use the distributive property. So we can go 10 times 2 is 20 plus 10 times 3 is 30 minus 8 times 3. So that's one way of writing that. And another way you could write this, I guess you could add the 2 and the 3 and multiply 10 times 5 to get 50. 50 minus 8 times 3, or you can multiply the 8 times 3. You could do 50 minus 24. So there's a lot of different ways you could write that, but there's some examples. So let's talk about similarity. We've talked about how one figure can be a scaled copy of another. And this relationship goes in both directions. For example, if triangle DEF is a scaled copy of ABC with a scale factor of 2, then triangle ABC is a scaled copy of DEF with a scale factor of 1/2. So we can make shapes bigger with a scale factor greater than 1, and we can make them smaller with a scale factor less than 1. And when we have a shape that is a scaled copy of another, like this example we were talking about, if we have this triangle here, and we have a scaled copy of that triangle, maybe 1/2, so this triangle here, from here to here, is getting smaller, so the scale factor is less than 1. But if we're going this way, from here to here is getting bigger, so it's a scale factor of greater than 1. So that we say that triangles ABC and DEF are similar. In the previous unit, we explored how translations, rotations, and reflections define congruent figures, right? Because the size didn't change, everything was exactly the same. Angles were the same, side lengths were the same. The only thing that's different, maybe it was in a different position, right? It might have been rotated, might have been translated or reflected. Now, once we include dilations, that can change the size, so they're not congruent anymore, but they are similar. So that's what similarity means. It means that it's the same shape, it's got the same angles, but the side lengths could be different. Side lengths have a scale factor, but it's the same shape. And again, they could be rotated, translated, and reflected, but they could also now be smaller or larger. All right, so let's see how this works. So we're going to start our investigation of similar figures by identifying sequences of translations, rotations, reflections, and dilations to show two figures are similar. So I have these two figures here. If they are similar, I should be able to rotate, translate, reflect, and dilate so that one is directly on top of the other one. So I'm going to start with the small one. I'm just going to trace it as best I can. Whoops, let me start over. Okay, good enough. And I can see this is pointing this direction, so I'm going to make this one point. So I'm going to rotate that. Looks like about 90 degrees, so we'll try that. Then I'm going to translate there to there. Now see this short side here is the short side here, and the long side here is the long side. So I'm going to have to flip this. I'm going to have to reflect it. Now I've got to rotate again. So maybe I didn't need to rotate in the first place. I just needed to reflect. Translate that down. Now I just need to make this bigger so that it is directly on top of this one. So I got to dilate it. Looks like a little bit more. All right, close, really close. Okay, so I did a series of translations, rotations, and reflections, and then a dilation at the end so that this shape is directly on top of this one, so I know that they are similar. It says triangle EGH and triangle LME are similar. Find a sequence of translations, rotations, and reflections and dilations that show this. So I should be able to do the same thing. If I take this small triangle and I translate L to E, and now I can see this is 2 squares long, and the bigger triangle is 4 squares long. So if I dilate it with a scale factor of 2, should be about the same size. Oops. Looks like I didn't draw that bottom line straight. So that one was just a translation and a dilation. So I translated it up 3 and to the left 2 times, 2 squares. And then I dilated it with a center of dilation at E and a scale factor of 2. Okay, hexagon ABCDEF, ABCDEF, and hexagon HGLKI are similar. Find a sequence of translations, rotations, and reflections and dilations that show this. All right, so I'm going to do the same thing. Oh, that came off. Okay, so the first thing I notice is this like L, this L shaped, it's pointing that way. So I'm going to reflect that. So it's that way. And then I'm going to translate E to I. Actually, I'm going to translate, that wasn't E, that was F. So I'll translate B to G. And then I'm going to dilate. So I'm going to make it bigger. I got to move this over a little more. And there we go. another thing I could do is I could translate the bigger figure and rotate and reflect it. And then scale it down. Okay, this last one. It says sketch figures similar to figure A that use only the transformations listed to show similarity. So number one, a translation and a reflection. So I'm going to start by tracing this figure here. Okay, close enough. All right. So this is going to be a translation and a reflection. So I'm going to translate it. Just translate it there. And I'm going to reflect it. And this is going to be sketch figure B. So it's the same size, just translated and reflected. So now we're going to do a reflection and a dilation with a scale factor greater than 1. So I am going to first reflect this. And let's do it this way this time. So I reflected it. And since it has a scale factor greater than 1, it's going to get bigger, right? So it would look like, we can make it like that. Well, it's just a reflection. So if we did that and made our line a reflection right here, that's what the figure would look like. Okay. Next one, a rotation and a reflection. So first, we're going to rotate. We'll just rotate it 90 degrees, about that point right here. And then we're going to reflect over this line right here. Actually reflect it that way. Reflect it left and right. Okay. And the last one, a dilation with a scale factor less than 1 and a translation. So we're going to translate, and since it's a scale factor less than 1, it's going to get smaller. That's it. So let's take some notes. So what does similar mean? Similar means that it's the same shape, but it gets bigger or smaller by some scale factor. So it makes the same shape. It's the same shape, only bigger or smaller. Angles are the same. I'm going to say same shape, only bigger or smaller by a scale factor. angles are the same. Side lengths could be different. Side lengths could also be the same if it had a scale factor of 1, right? So scale factor of 1, let's make a special note here. Scale factor of 1 means that the figures are congruent and similar. Okay, so what's a way you can determine if two figures are similar? You can perform a series of translations, rotations, reflections, and dilations so that the figures are directly on top of each other. So perform a series of translations, reflections, rotations, and dilations so that it takes one of the figures to the other. So that's it. See you guys next time.